Hello, Dr. Lewis. It's Alexis's podcast. So, that's my nice drawing. And let's get started because my last video was too long. So for our first question, we have to find the limit of f of x as x approaches 0. And our equation is tan times 2x over x. So we're going to use L'Hopital's whatever the name is, rule. And that means that we're going to find the derivative of tan 2x over the derivative of x. So the derivative of tan, as we know, is secant squared x. So the derivative of x is secant squared, well, tan is secant squared x. Good God. There's 2x, and the derivative of 2x is 2 all over 1, which is the derivative of x. So then we're going to plug in our numbers. So secant squared 0, we're going to plug in because we're going to try and find the limit of 0. And times 2 all over 1. And we know the derivative of secant squared 0 is going to equal 1 times 2, which all over 1, which equals 2 over 1, which equals 2. So the derivative of that is 2. On to number 2. Well, there we go. There's our answer. Next, we have to find the limit of f of x. I didn't write any f of x's, huh? As x approaches 8 from the right. So, if we were to just plug in our 8, we know that this would give us an undefined number. And it's negative 8, I think. As x approaches negative 8 from the right. So, what was that? Negative 16 over 0, which we can't do. So, we're going to find the limit of f of x as, I don't know why I did that, as x approaches 8 from the right. So, we have to first find a number that is somewhat close to negative 8, as close as we can get it. So, negative 8, negative 7, negative 9. And because we're coming from the right, we're going to get a number right between negative 8 and negative 7. And we learned in class that we're going to use negative 7.5. That's going to be our number that we're going to plug in instead of 8. So, that's going to be 2 times negative 7.5 over negative 7.5 plus 8. And we don't have to have an exact number. And looking at this number, we know that our answer is going to be positive. So our answer is going to be a positive infinity. And then we were asked to find the vertical asymptote for this question. And we know that because we have, we're looking for positive, for 8 as it approaches from the right, and our answer was positive, our vertical asymptote is going to be a positive 8. Alrighty. On to number 3. We have to find the limit of f of x as x approaches infinity. And this was a tricky one, but I'm slightly smart sometimes. And we know that looking at this, we have a radical. That's what's going to mess us up. So our largest exponent in the radical is x to the negative 6. But I want to find a way that I can simplify this number. And usually when I see a radical, the first thing I do is draw out this, because that's what I got to do. And we have x to the negative 6. So we know that this is the same thing as writing x to the negative 6 to the 1/2, which is actually equal to x to the 3rd power. So that's the number that we're going to bring up here. So we have the limit of f of x as x approaches infinity, and when we use infinity, we have to divide by our greatest exponent, and we change that exponent to negative 3, well, to positive 3x to the 3rd power. So we're going to start plugging that in. 4x over x to the 3rd power minus 3x squared over x to the 3rd power all over, and in in the bottom, we're actually going to leave that, we're going to do a different way, and we're going to leave it as x to the 6, but because it's under the square root, we're going to put 1 over x to the 6, and that's the same thing as saying x to the 3rd power or the square root of, okay, you get it. And we're going to multiply that by our thing right here and pretty much distribute this number out to these two numbers. So this is going to give us, I'm going to go ahead and start plugging in our infinity signs. So infinity to the 3rd power minus 3x squared over infinity to the 3rd power. We know both of those are going to equal 0. We're going to distribute this number to these two, and that's going to give us total the square root of x to the 6 over x to the 6 minus 9 over x to the 6. And we know that's going to also equal 0. Go ahead and put our little infinities in there. So this is going to be 0, 0, 0. So I'm not actually crossing it out, but down here we can see that we have 0 minus 0 all over x to the 6 over x to the 6 is going to give us 1 minus, we know the infinity there is going to give us 0 as well. So our answer is going to be 0 over 1, which is essentially 0. And this one also asks for our horizontal asymptote instead of our vertical. And we know that because we're actually trying to find, well, we just found it pretty much. And our horizontal asymptote is going to be in terms of our y. So the equation is what it's actually asking for. It's going to be y equals 0. So that's our second answer for number 3. Now, for our longer question, we have our graph right here. And the first question for 4a is asking us to find the limit of f of x as x approaches -4. So on the graph, we're going to go to -4 and look to see where our values are approaching from the left and from the right. Where are our graphs approaching? Our lines or asymptotes, whatever. So from the right, we see that it's approaching up here around, you know, about 3 or so. But it's not really touching anything. And also from the left, it's approaching a value that I'm not going to say because that's in our next question. And it's also not touching our -4. But either way it goes, no matter what it's touching, from the left and from the right, our values are not the same. So that means that the limit of f of x as x approaches -4 does not exist. I'm going to put D and E for do not exist, baby. And then for letter B, we have to find the limit of f of x as x approaches -4 from the right. That's what our positive sign means. So let's look at -4 from the right. We see that our line is kind of going up. It never ends, and it never touches -4. It's never going to. It's just going to keep going in this infinite direction. So as x approaches -4 from the right, our answer is going to be positive infinity, meaning that it's never going to touch this line, and it's not going to stop going. So it doesn't really have like an exact number, you know. It's positive infinity. And then for 4c, we have to find the limit of f of x as x approaches -4 from the left. So looking from the left, we see, similar to our other one, it's going towards -4, but it's never going to touch it. It's really close, but it's not going to touch. And it's going in a negative direction infinitely. So our answer for letter C is going to be negative infinity. For 5a, we have to find the limit of f of x as x approaches positive infinity. Let me put a positive right there. And then looking in this direction, that's where our positive infinity is going to go towards. And these are x values. And we see that it's kind of close to 1. So infinitely, never ending, our value is going to be going towards 1, our x. So that answer is going to be a positive, whoa, not positive, -1. And then for 5b, it asks for the limit of f of x as x approaches negative infinity. So looking towards the left, which is where our values go negative, we see that our value is kind of on our line. It's going towards negative infinity. It's never stopping. And what's that value? 2. So the limit of f of x as x approaches negative infinity is going to be a positive 2. And that is my podcast. Hopefully it's under 10 minutes, and hopefully I get a great grade on it.